sum from n equals 1 to infinity of n plus 3 all over n squared plus 3n plus 2. We want to use the comparison test to see if the series converges or diverges. So with the comparison test, we can use a direct comparison and then use a limit comparison. So we're going to go over both ways. But first, for the direct comparison, we have to find either something bigger or smaller, depending on whether we think this converges or diverges. So a good way to start is to look at the most dominant term in the numerator and the denominator. N is greater than 3, and then n squared is greater than 3n and 2. So in the long run, this ratio will look like 1 over n. We know 1 over n diverges, so we want to find something smaller. If something smaller diverges, then something bigger will also diverge. So let's come up with something smaller than n plus 3 and then n squared plus 3n plus 2. In order to get something smaller, we have to decrease the numerator and increase the denominator. So why don't we just remove the 3 from the numerator? And now for the denominator, why don't we turn the 3n and 2 into n squares? So like those will be the coefficients of n squares. So that's like n squared plus 3n squared plus 2n squared. So this will be n over n squared plus 3n squared plus 2n squared is 6n squared, which is 1 over 6n. So 1 over 6n, we know that diverges by the p-test. And so by the comparison test, the direct comparison test, our original series diverges. Now using the limit comparison test, we're going to compare a limit to 1 over n, since that's what it simplifies to. So we're going to look at the ratio of this limit. So it'll be n plus 3 over n squared plus 3n plus 2 all over 1 over n. Now dividing by 1 over n is the same thing as multiplying by n. So the n is going to go at the top here. So the n is going to be multiplying the n and the 3 to get n squared plus 3n. And the denominator, we have n squared plus 3n plus 2. Now at this point, we can divide everything by n squared. So we have 1 plus 3 over n all over 1 plus 3 over n plus 2 over n squared. The 3 over n's are going to go to 0. And then 2 over n squared as well is going to go to 0. So we have 1 as our limit. So this means either both series converge or diverge. And you may be asking, well, what is the other series? The other series was 1 over n. So it was the original series and then the 1 over n series. Because 1 over n diverges, that forces the original series to also diverge. So by the limit comparison test, our series diverges.